All right. Good afternoon, everybody. I'm Sunil. I'm actually a principal scientist at AWS based out of San Francisco. So wanted to talk today about some of the advanced features and advanced notebooks. So I wanted to talk about how you could do parallel training. That is, train on multiple tracks. How do you modify the neural network? And how do you actually modify elements in the assets or the world itself? So we'll walk through that. All of this, what I'm going to show you today, is in GitHub, so it's accessible to you, and you should be able to replicate this anytime. Just a brief sort of recap. There are two main components with DeepRacer training. One is the actual reinforcement learning training, which happens on SageMaker. And the other part is a simulation piece, which is hosted in AWS RoboMaker. Now, both actually are connected. We have connectors via a Redis server that is hosted inside of SageMaker, and then we have a connection through S3 where the exchanges of the actual model checkpoints happen. Now, the reason behind that was we wanted to make sure that each part was independently scalable. So if you had the simulation environment and the training all in the same node, then it wouldn't be independently scalable. Like, they would be fighting for resources. So what that allows us to do is scale each part. So let's say you had 10 tracks that you wanted to train. Now, you may ask, why do you want to train on 10 tracks or n number of tracks at the same time? Now, if you want to build a really robust model, the more images, more diverse images or experiences that you can give to the model actually helps it train faster and better. That's the whole idea here. So, this notebook that we have here goes through how you can change the simulation assets, right? Like, so currently in the console there are fixed number of tracks, but you may want to modify the track a little bit, right? Like, you might want to have a wooden track instead of a carpet track. You might want to change the friction elements on the track, or change a little bit aspects on the car so that you can customize it to what you have perhaps at home laid down a track, right? So this walks you through how you could add a new track, and we have documented places where the world files in Gazebo simulation and all the textures, etc., are present. So you can use this, and it's just XML. Like, most of it is just XML. It's readable, and so we have documented that so that you can modify some of the aspects. And we have, we'll release a blog pretty soon, but we have some of the aspects that are captured here. In terms of the file structure, there's a whole blog that walks you through what are the Python files, the code files that are present, and what each is on sort of the simulation world, or something that you guys want to deep dive into. I want to make sure this is interactive. Maybe I can show. It's okay. Does anybody want me to dive into the SIM app, or any interest there? No? Okay, I'll continue. So the other aspect, like, once you have, I'm not going to explain the imports, but there's basic setup code for Python setup and parameters and permissions that you get to set. But the real meat sort of comes here in terms of what all can you customize, right? So this is sort of the summary of the earlier description, what I had, which is the distributed memory, that is memory inside of Redis, where we capture the back and forth in terms of messaging between the simulation and the DeepRacer environment itself. And then what you can change is the model architecture. So in the console, it's a fixed number of architectures that you can choose between, but with the notebook, what you get is you get to change the environment, and the way to do that. And the way to do that is through changing the presets. So your default preset file looks like this, where you're pretty much choosing a very static set. So you're choosing a very default setting. But what you can do is you can declare a layer, your own custom layer, and code that in Tensorflow in this environment. So in this case, what we've done is we've added attention mechanism on top of the convolution layer, and what you can do is basically use this as another building block over the convolution and mix and match and build your own network. So you can see here is now, instead of using a 3-layer just CNN, we use a 2-layer CNN with the 3rd layer of convolution having an attention layer. So it's super easy, right? Like, this is already usable. Like, you don't need to code. Like, you can take the code and extend this and build your own. Perhaps you want a deeper network, or you want to have different sort of filters that you want. So all that is you just package it in this code. And I know this is a pretty dense, but all of this is actually documented in the blog. We walk you step by step as to what the network is, how you can modify. So, as I said here, yeah, all of this is documented in the blog, along with each of the code. Like you can see here, talks about the preset as well. And then you can, of course, change other parameters, like you can increase the depth of your middleware, increase the power, decrease it, whatever you please. So everything is customizable now. And, you know, who knows? I mean, if you want to try adding perhaps a recurrent layer as well, it is possible with this method. Any questions on customizing the neural network? Okay. Now, let me actually try and I'm going to try and kick off a job. Yeah.
Can you use? Do we have to use just TensorFlow?
Yeah. Currently it's best integrated with TensorFlow as far as the notebook is concerned. But we're opening up certain parts so that it's actually possible. So the underlying architecture actually supports MXNet as well, because that's present in and packaged in RL Coach and in SageMaker RL. So it's possible. So that'll be another thing. If you're interested, we should talk more and see if you're interested in perhaps different frameworks that you might want. Okay. All right. So I don't know what state my notebook is in, so I'm just trying to shortcut a few things to make it faster. But the idea is, as you can see, like this is my the training notebook. So this is the SageMaker node that we spin up. But the real sort of power now that I talked about is we might want to train on multiple simulations. So so what I can do is I can just take a bunch of tracks, and a bunch of tracks are available. And if I wanted to train on 5 different tracks, I just create a list where I talk about the base reinvent track, the AWS track, virtual track. As you can see, like I can just populate how many ever number of tracks that I want to train all at the same time, and and we do that, and I can just spin up a job. As I said, I don't know which state the notebook is in, which is why I was trying to shortcut. But all you need to do is enter that, and you should be able to run all on multiple notebooks. So, and this is also documented here in the blog. So you can see you just do all of that, and it should be available. So another sort of thing that we do to better understand is changing and configuring the evaluation runs. So what we try and do is you actually hit, you can change the number of trials, but also you can iterate through pretty much all the checkpoints that, let's say you've trained a model and you want to evaluate on a different track. So you can just choose the track and point it to the S3 location, and it can iterate through all the checkpoints. Let's say you have 100 different checkpointed models. It can run through all and give you statistics on how each iteration performed. So now you have a sense of how your model trains and where it's converging at. And this is super helpful because then you get to understand at what point the model converges, and you really don't want to train if your accuracy, if your model gets 0.001% improvement by training another 5 hours, it's probably not worth your time. So you get a good understanding of, well, I'm getting good lap times, the laps are completing, so perhaps this is a good place for you to stop the training. So all of that is packaged in the notebook. It's all available. And all of this is because, see, what we want you to do is not just like race here. How do you learn? How do you take it to the next level? So what we have done is we actually have a competition at a top tier machine learning conference called NeurIPS, where we are doing AI driving Olympics. That's a racing part. And you can use this notebook here, and you can actually build models where you're actually doing simulation to real transfer. So we're going to have evaluation where the track has a lot of lighting and perceptual changes. So half the track is carpet, half the track is wood. So how does your model now change, because the friction and the perception changes? So can your model really adapt to how it changes? So we've got that challenge, and the finals are going to be next week. There's still time to participate. We're going to give cars away, so you can use the notebook. You can use the notebook and the link here, where we have in our workshop GitHub. It's called the AI Driving Olympics. So I encourage all of you to go try, build models. There are lots of prizes to be won. We are giving away a DeepRacer Evo, which hasn't been released. So you get a chance to win that. and really, I would say like go beyond what you're able to do here and really challenge the reinforcement learning part there. So please come talk to me or Sahika there. We can give you more information. If you just search for Driving Olympics, driving-olympics.ai, all the information's here, and the racing event. So whatever I talked, all the advanced stuff, you should be able to showcase and participate there. So there's still time to submit your models. It's super easy, but it's going to be a lot more fun trying to make your model work in a very heterogeneous environment. So we think it's going to be cool. Another quick thing that I wanted to talk was just some of the analysis. So we have a notebook that we call log analysis. So every time you run something, the training or evaluation, we collect a lot of logs. It's very useful for you to debug. So as an example, you get to actually see what was your reward per iteration, so that you have an idea of where the model is converging. Then you get an idea of a reward heat map. Where was the best reward? Like you write a reward function, and then you can use this to debug and understand if your model, what you coded, actually translated and how you wanted it. And then you can actually plot the paths that the model took every time it ran. So you have an idea of, oh wow, okay, why is my model going wide? Oh well, look, it found a shortcut, right? Like it's going wide and gets a straight line on the curve, and they're like, oh my god, that's so smart, right? Like because that's the shortest path that it can take, so it goes wide and cuts it in. And so it's actually looking at what is the fastest path that you can get around the track, and that's sort of what you want to cultivate and actually program or a reward so that you can actually get really powerful there. So yeah, we have a lot of that, and if you want to do like simulation to real debugging, we have some heat map generation, so you can give real images and see what your model is looking at. So you now get an idea of interpretability, right? Like, okay, I'm rewarding the model to look at the center line, and is that what's happening? Or on a turn, what should be the model looking? Of course, right? Like it's to make a left turn, it has to understand where the corner is and the turn is coming. And you can see here, the red being the area of focus, you can see it focuses on the curvature because that's what is telling it that it needs to turn. So you can use this as a tool to debug and really understand where the model what the model is doing. And in the virtual world, you can plot like heat maps like this, where you have an understanding of at a more fine-grained level as to not just the path that the model took, it also gives you what the speed was while it was taking it, right? Now, ideally, what we want to show, what we want to see is the speed, high speed 5, right? Like that's what we want to see all around the track. But it might not be possible because, at a turn, like your exit velocity at the hairpin may take you out. So you might need to slow down, speed up, and then slow down again, depending upon what you're doing. So all of that, you can go into really fine-grained detail to actually understand what's happening. And of course, from a reinforcement learning point of view, you get a lot of different metrics here to understand the entropy, the rewards, and the relationship between any of these fields to better understand if anything on the RL side of things can be tweaked to get better results. So yeah, that's pretty much what I had in mind to sort of expose and talk. Happy to answer more questions here. I highly encourage you guys, especially since you're here for the advanced stuff, I highly encourage you to participate in the NeurIPS challenge. So please go train your model today and send your submissions. All of that, the notebook should be very self-guiding, and it should be a lot more fun, like actually training. Imagine like your car adapting to different surfaces like you as a human would do. So super cool. Thank you so much.
Thank you, Sunil. Do we have any questions at all for Sunil? We've got one from Thomas.
Yeah, so in one of the papers, the articles that you published, you said that you were evaluating each checkpoint that was generated in training. How did you trigger it? Did you use like lambdas or?
Yeah, no. So we built some custom code where we, as a model is training, we kick off an evaluation job. But what we have done is we've actually made it accessible to you in a slightly different way. What you can now do is once you train the model, you can run an evaluation job, and you can tell it, you can point it to the S3 bucket, and what it does is it iterates through all the checkpoint numbers. So let's say you have 50 checkpoints, it'll go start with 0 to 50 checkpoints and give you, and run 10 laps or whatever the laps you configure, it's going to run those. Then you get the data from the logs, and then you can say, hey, okay, wow, checkpoint 29 had the best lap timings, and that must be the best point where the model has converged. So you can do that. And that's in the GitHub, the advanced workshop, the NeurIPS one that I described. It's in there.
Thank you very much. Do we have any more questions at all from the audience? Any more questions? All right, let's give it up for Sunil Mallya. Thank you very much.
Thank you, guys.